Have you ever wondered what happens when you open Instagram, watch a YouTube video, or check your bank balance? You tap button and within seconds the information appears on your screen. But where that information actually stored? How does your phone know what to display? The answer lies in one of the most fundamental software architecture patterns ever created, that is client server architecture. In this session, we will break down what client server architecture is, how it works, why it is so widely used, and where you encounter it every single day. At its core, client server architecture separates responsibilities between two parties: the client, which requests information or service, right? The requesting party, and the server, which processes those requests and provides the response. This is a very basic, simple words. Right? Think of it like a restaurant. You, as a customer, are the client, and the kitchen is a server. You place an order, the kitchen prepares the food is delivered back to you. Right? You are the client, and the kitchen is the server. You get food from the kitchen. That is client server architecture. Right? Similarly, in software systems, the client sends a request. The server receives that request, processes that request, and the server returns a response. This simple concept powers most applications we use today. Now, let us see what is client. Server, this is a request and response. Now, let us see what is client. A client is any application, right? Application or a device that requests the data or service. This requests the data or service from the server, right? The client examples include mobile application, mobile applications, right? Web browsers, web browsers, and desktop applications or any smart TVs, right? It can be anything. Now, when you open Instagram on your phone, your mobile app acts as the client. That Instagram app that you have installed on your phone is the client. When you visit a website through Chrome or Safari, your browser acts as the client. The client's primary responsibility is presenting information to users and sending requests when data is needed. What it does, it presents the information to user. Maybe you are selecting an image, or you are typing a text message, that it provides the text box where you can enter your data, right? Basically, the user interface. the UI that you see as soon as you log into Instagram or any web application for that matter, right? What it does, it presents the data, and based on your action, it sends the request to the server to get required information, right? This is the client responsibility. Now, what is server? Server is responsible for handling requests and managing business logic. Servers typically perform tasks such as authenticating users, right? As soon as you make a request, first one needs to validate who is making the request. That is authenticating, right? Now, processing the business rules. Maybe in case of banking, right? The user is authenticated. Now, if you are requesting to view the balance, now it has to process that request, saying it has to get the balance, right? Now, to get the balance, it has to talk to database, database, right? And this, once it is having the response, it needs to send it back to response, send it back to the client. Okay. Now, what are the client responsibilities? Client is presenting the data to user. That is the presentation layer, nothing but the user interface. And receive the collect the client's data or request or actions and send it to the server. That is client responsibility. Server responsibility, authenticate who is making the request, process that request, and send the response back to the client. Right? Now, there are some understood rules, which are client usually do not store sensitive information or business logic. That responsibility belongs to server. Right? Client will not store the username or password for the banking application or password. Right? Only server, once client receive the details, it will not store, but it will just pass on it to server. Server is the one validating that username and password. Right? Now, how client server communication works. Let us understand with a simple example. Imagine you are using Instagram again. Right? You open an application. The Instagram app, acting as client, sends request to Instagram server. Now, this is your Insta app. Insta server, right? The Instagram app, acting as client, sends a request to Instagram server. Now, the server receives the request. It is sent request. That is step number one, right? Now, step number two, server receive the request. Right? Let me also write this in different color. One, step one, send request, right? Send request, receive the request, second step. Now, third step, the server validates your identity and determines what content should appear in your feed, right? Now, server validates the identity of user. That is nothing but our authentication, right? This is also happening at server side. Now, the server retrieves the required data from the databases or supporting systems. Now, it is validated who is making the request. Now, server access database get required information. Right? Now, once it has the required information, the next step is it sends the response back to the client. That is number 5. Send response. Right? Now, number 6 is client display the content in app. Okay, this is the whole journey. Right? First step, client sends the request. Second step, server receives the request, validates who is making the call. Now access the database, send the response back to the client, and client displays that content in the application. This is the whole one cycle of client server communication. Right? From user's perspective, this entire process feels on the spot, instant, right? Behind the scene, however, multiple systems are collaborating to deliver the experience. Example, the server is talking to database. The request response model is the foundation of client server architecture. Right? Um, Let us understand one more real world example. Let us consider an online shopping application. A client would be a mobile shopping app, a website running in a browser, right? Same example. Now, this is the Instagram, and another example we can take just for understanding any online shopping app or a website running in a browser. A server could provide services such as for online shopping apps, a server will handle product catalog. Right? It stores the product catalog and it handles user authentication. It handles cart management when you add a particular product into the cart, right? And it can handle payment processing or order tracking. All of these are server responsibilities, right? When a customer search for a product, the client sends the request to the server. The server searches the product catalog. The server returns the matching product. The client displays the result. Right? This separation allows each component to focus on its own responsibility. Right? Here also server and client and server. Right? Now, we have understood client server architecture with two examples. Right? Now, what are the advantages of client server architecture and why it has been in so much of demand and has a popularity over decades, right? It provides centralized management because business logic and data can be controlled from central location, right? This server central location. Now, improved security. How sensitive information remains on server instead of being exposed to client. devices. We have seen that, right? The username and password are stored at server. When a client sends username and password, server itself validates whether the received credentials are correct. Client is not storing anything, right? That is how it provides security. This is in like very simple words, right? Now, um, easier maintenance. Updates can often be performed on the server without requiring changes on the every client device. If there is a new product to be added in the catalog, there is no change required in the client side, correct? Scalability. Additional servers can be added to support growing user demand. Again, without affecting client. Client does not even know that there are more servers added or the system is scaled, right? Now, resource sharing. Multiple clients can access the same services and data simultaneously, right? Multiple clients, right, can send data to server. There is no such restriction, right? These benefits make client-server architecture suitable for everything from small applications to global platforms serving millions of users, the enterprise applications. Right? As the client-server architecture is a very popular and feasible architecture, but there are some limitations to that. Now, the server dependency. Right? Now, if we see the client is the completely dependent on server, right? What if server goes down? Down. Complete operations are stopped. This is single point of failure, right? Single point of failure. This is one disadvantage. And scalability bottleneck. If the um, system is poorly designed, servers can become overloaded during the high traffic. If there is no proper scalability planned, right? If the server is not distributed. Now, if millions of clients started calling the same age-old server, then definitely the server will not be able to handle that amount of traffic, which again makes server to go down, right? And network dependency. The communication relays completely on network from client to server and server to client, right? Network communication is the primary bottleneck. If network goes down, the complete system goes down, right? Despite these challenges, modern technologies such as load balancing and cloud infrastructure, scalability has helped client-server architecture mitigate those concerns. Again, in architecture, everything is a trade-off, right? If we are able to manage the scalability, we can handle more users, right? If we are able to distribute the server onto cloud infrastructure or any other way, then we'll be able to handle availability, right? The server is available and can handle more requests, can be reliable. This is how we mitigate the challenges. So, in nutshell, client-server architecture is a model where clients request service and server provide them, right? It's a simple, scalable, secure, and forms the foundation of most modern software systems. Whether you are using Instagram, Netflix, online banking, or e-commerce platforms, you are interacting with client-server architecture every day. And understanding this pattern is one of the first steps towards thinking like a software architect. In all our previous sessions, we have seen from a very basics of understanding what is software architecture, and we have moved to architectural characteristics, identifying, incorporating them in the um, architecture design and building, right? Now we are understanding architectural patterns. Right? So client server architecture is worth starting with understanding more architectural patterns or styles because this is the simplest one, this is the more reliable, this is widely used. Right? So here in this session, we have covered client server architecture. In upcoming sessions, we will see more such architectural patterns. This session is part of software architecture series. There are more topics covered on software architecture. Please check the series. Thank you for your valuable time.